Hi, today we're going to talk about how to find volumes of solids with known cross sections. Here is the formula that we use. A of x here represents the area of the cross section, which depends on what the shape is. So there is no universal way of writing that, and it really depends on what you have. So here's an example, and we're going to do a few problems. The region bounded by this is the base of a solid. So this region here that is bounded between the two curves, the curve y equals x squared and the line y equals 2x. And the cross sections are going to be perpendicular to the x-axis. So our cross sections are going to be going this way. And we have 4 different problems that we're going to take a look at. So let's start with the simple one. The most basic one is when you have a square. So when the base is the square, the cross section is square. This is the base, which represents the length of one of the sides of the square. And to find this distance, it's the difference between the two curves. So for that one, the side is going to equal to the absolute value. Well, actually, if we do it with the positive one, the line is above the curve. We're going to get this. And then the formula for the area is going to be 2x minus x squared, because to find the area of the square, we're going to square the length of its side. And what we're going to do next is we're going to set this up into our formula. We should know that our limits of integration will be from 0 to 2, because we're going along the x-axis. So then our setup for the volume is going to be the integral from 0 to 2 of the area function, which is this, dx. So it's the integral from 0 to 2. Have a bit of algebra to do. 4x squared minus 4x cubed plus x to the 4th. Dx equals, we are going to integrate it now, so we're going to get 4x cubed over 3 minus x to the 4th plus x to the 5th over 5, all going from 0 to 2. Now we substitute the values. So this is going to be, first we substitute 2, that's going to give us 4 times 8, 32 over 3, minus 16, plus 32 over 5, minus, I always like to remind students that it is going to be minus 0. Okay, and now it's just a matter of calculating that. And we can easily do some math. For the sake of saving time, I can do this on my calculator. And so we got 32 divided by 3 minus 16 less 32 divided by 5. And we have 16/15ths, which will be the volume of that solid. So the next one is going to be a situation when the cross section is a semicircle. Just to explain this a little bit better, let me go back to this for a second. So we have this this line, and the curve here, and we have this cross section going. So if you look from the side, we are going to get squares, except these squares are sitting vertically. So now we have a semicircle whose diameter is the base. So what we have is this, and like this, and if I do a side view, I'm going to get a semicircle. So what we need to remember is we need to find the area of the semicircle, which is half the area of the circle. We do need to figure out the radius here. So the radius is going to be 1/2 of this distance between the two functions, because that distance represents the diameter. So 2x minus x squared, which we can rewrite as x minus 1/2 x squared. And then the area formula will be, so how do we find the area of a circle? And we multiply it by 1/2, so 1/2 pi times radius squared, which is x minus 1/2 x squared squared. I would highly recommend, well, what we can do for the sake of making our work easier, we can probably keep the 5/2 pi over 2 outside and leave that here. So what we are going to do is we're going to substitute that into our formula. So for the volume, we're going to do the integral from 0 to 2 of pi over 2 times x minus 1/2 x squared squared dx. I would probably recommend take pi over 2 out, and then here we're going to expand, so it's x squared minus x cubed plus 1/4 x to the 4th dx. So continuing with this, we are going to have pi over 2, and here we can integrate this, so it's x cubed over 3 minus x to the 4th over 4 plus x to the 5th over 20, going from 0 to 2. So it's pi over 2 times, substituting 2 is going to give us 8/3 minus 16 over 4, which is 4, plus 32 over 20, which I'm sure you can simplify, minus 0, because when you plug in 0, you're going to get 0 here. Okay, and now we are just going to do this. So we'll take care of the fraction of the expression inside the square root first. So 8/3 minus 4 plus 32/20 is going to be 4 over 15. So this is pi over 2 times 4 over 15, which, if we simplify all that, is going to give us 2 pi over 15. Okay, so that's the volume of this. Alright. In general, I'd probably say semicircles are a little trickier because of the reason that you have to do, you have to remember that the base is going to be the diameter, and you have to remember to take half of that, which is exactly what I did over here, to get the radius, because the formula for the area of the circle is pi r squared, so you need the radius. Also, the reason we got another half here is because we are doing half the circle, semicircle, so the formula will be 1/2 times the area of the circle. Right? Now we're going to take a look at the situation when we have a rectangle whose height is 3 times the base. So let me go back to the diagram for a moment. So if this is the base of our rectangle, then the height, what's going up vertically, is going to be 3 times that. So we know that the base is going to be 2x minus x squared, but the height will be 3 times 2x minus x squared, since it says it's 3 times that. And the area function here will be the product of these two. That's how you find the area of a rectangle. So it's going to be 3 times 2x minus x squared, because we're multiplying these two quantities here that are the same, so this is the expression for the volume. So then I can write that the volume is going to be the integral from 0 to 2 of, since 3 is a constant, I would probably take it outside just to make it easier to work with. And now we can go ahead and expand this. So it's going to be 3 times the integral from 0 to 2. This is going to be 4x squared minus 4x cubed plus x to the 4th dx, which is going to give us 3 times the it's actually the same integral except the 3 that we had in the first problem there, which was 4x cubed over 3 minus x to the 4th plus x to the 5th over 5, going from 0 to 2. So it's going to be 3 times, and the answer for this one, we did not have 3, if you go back to A, was 16 over 15. Which means our answer is going to be 16 over 5. Okay. And the last problem we have here, we're going to do a triangle whose height is 1/2 of the base. So, if I go back to the diagram for a moment, so this is the base of the triangle, then the height going up is going to be 1/2 of that. So we know that the base here is going to be 2x minus x squared. The height is going to be 1/2 times 2x minus x squared. The area, I want to remind you to find the area of a triangle, is going to be 1/2 times the height times the base, which all in all, in our case, will become 1/4 times 2x minus x squared squared. Okay. So we plug it all into our formula. 1/4, since it's a constant, you can place it outside of the integral. This way it doesn't get in the way. Then we have 2x minus x squared squared dx. I'm not going to work it out completely, simply because if you look at even the previous problem here, except for the 3, the integral itself is exactly the same. So essentially what you're getting here is 1/4 of whatever the integral here gave us, which was actually 16 over 15. You can work it out and you will see it. So in this case, it's going to be 1/4 times 16 over 15, which is going to be 4 over 15. Okay? If you have any questions, feel free to ask them in the comments section, or let me know what else you might need help with. Hope this helps.